Algebra 2 Trigonometry Regents, Circle Equations, Day 2. The previous video, we learned about the basic properties of a circle equation. Then I have one here on my first example, how this would have a center at -3, +3, and its radius would be the square root of 53. There's really two things we're going to attempt to cover in this video. First is how to solve a circle linear system like this. This is the equation of a linear equation. I see that because none of my variables are squared and x and y are being added. And we're actually going to have a video later on this chapter about how to recognize the types of equations for what their graphs are and determine if they're functions and things like that. But for now, I would just need to know we want to solve. We want to see where these things cross. This is a line, this is a circle, and we want to know the coordinates of where these things intersect, just like we do with all of our system questions. Now, when it's multiple choice like this, you could guess and check, meaning you could test these coordinates to see which one works for both equation. X plus y equals 5 is pretty simple, but 2 plus 3 is 5, 5 plus 0 is 5, -5 plus 10 is 5, and -4 plus 9 is 5. So these all work in this equation. So then you could test them in here and see which ones work for this, and only one of them will. Now, you could definitely do that. But well, I shouldn't say when I give this question on an exam, it will not be multiple choice. And so you'll have to solve it algebraically. You'll have to do the work. So the way to do that, and so that's how I'm going to show you how to do this problem. And so what we want to do is we want to take our linear equation and solve for one of the variables. It could be solve for x, solve for y, it doesn't really matter. So first thing we're going to do is to solve the linear equation. Solve the linear for a variable. In this case, we're going to solve it for x. So I'm going to turn this into an x equals equation. And so how am I going to do that? I'm going to minus y to the other side, so it's going to become 5 minus y. So we just solve our linear equation so that one of our variables is alone. That may require one or two steps. We'll see. Number two is you're going to substitute. So I'm going to take, since x equals 5 minus y, I can take the 5 minus y in the other equation and put it in for x. See, basically what you're doing when you do these equations algebraically is that we can't solve an equation when there's two variables. But if I could replace my x with something with a y, then I'll only have y, and then I can solve the equation. And that's exactly what we're going to do. So I'm replacing my x with 5 minus y because I've found out now that x equals 5 minus y. And that's what substitution is. So I'm going to replace this x with 5 minus y. And then I still have the plus 3. And that's squared plus y minus 3 squared equals 53. And now I'm going to evaluate this. First of all, I can clean this up a little bit. I have a 5 and a plus 3, so I can make that 8 minus y plus y minus 3, both being squared, equals 53. And so what I can do now is I can solve this out algebraically. I can square these and evaluate. So 8 minus y squared. Now this is a binomial squared, and we've talked about this a lot. Remember, when we have a plus b squared, a binomial squared, it's equivalent to FOIL, a plus b times a minus b. So this is the same as 8 minus y times 8 minus y. But we do have a shortcut for that we could kind of do it in our heads in a sense. Now, if you don't like to do this part in your head, you don't have to. You can certainly write it twice and do FOIL, combine the middle terms, and you'll get the same result. But if you remember how we do this in our head, that we like to square the first term, multiply these together would be AB, but you double it, and that would be you're combining two middle terms from FOIL, and then square the last term. And so that's the formula to do this. But again, you could just do FOIL. So 8 squared is 64. Times each other is -8, doubles to -16y, right? Times each other would be -8y, so double it to -16y. And negative y squared is plus y squared. And then the same thing over here. Y squared is y squared, times each other is -3y, doubles to -6y, and then -3 squared is +9, and that equals 53. Combined like terms, we have 2y squared. Between the -16y, -6y is -22y. And between your 64 and your +9, you have positive 73, and that equals 53. Set it equal to 0 is going to be 2y squared minus 22y plus 20 from when you subtract 53 over. Then factor and solve. Now, you could do AC factoring here. You could do quadratic formula. You could do completing the square. But we could just divide everything by 2 also and make it a little bit easier. So y squared minus 11y plus 10 equals 0. Factors to y minus 10 and y minus 1. And so you get y values of 10 and 1. And remember, these don't go together. They're the y values of your two coordinates. And so you got to find their x values that go with them, but you could just use your linear equation, x plus y equals 5. So the x plus this equals 5, x would have to be negative 5. And you can substitute that in here if you can't do it in your head. But 10 and negative 5 add to 5, and 1 and 4 add to 5. So you get really two solutions. You get negative 5, 10, and 4, 1. Now only one of those is here, the negative 5, 10, 1. And so that's the answer to this question. But if this was a written out question, I would want both answers there. So we kind of stopped filling in our steps here. So we solved for a linear, we substituted, and then we basically solved. And that include factor, or let's say first you want to set equal to 0, and then you can say factor slash solve. And the process along here of binomial squared, like terms, stuff like that, we're not going to write all those steps out because this is stuff you should be able to do very easily at this point. So that's how you solve a circle linear system. There's one other thing we're covering in this video, and that is how you can get an equation that looks like this to be a standard circle equation. And what we're going to use is our process that we already know, completing the square. The first thing we have to do is we're going to group your variables together. So see how I have let me change colors. See how I have an x term here and an x term here, and then a y term here and a y term here. And then you have a constant. And if you remember, for completing the square, the first thing we did was we set it not equal to 0, but we set it equal to the constant. So any numbers that don't have variables, they got to be moved to the other side. And I want to rearrange this so my x's are together and my y's are together. Just make sure that everything keeps the sign, like this negative 2 is, this negative is going to stay attached to the 2, and the positive is going to stay attached to the 6. So let me show you how I'm going to rewrite this. I'm going to write it as x squared, and then minus 2x, and then plus y squared, and plus 6y, and I'm going to set it equal to negative 3. So I subtracted 3 over, that's my constant being subtracted over, and I grouped together these two pieces and grouped together these two pieces, just rearranged it a little bit. Now what we're going to do is the process of completing the square, twice. Once for the x's, once for the y's. If you remember the thing for completing the square, the step was you had to add something to both sides. So we have x squared minus 2x, and I'm going to add something to both sides. That something comes from your b term divided by 2 squared. B divided by 2 squared. And the b is the coefficient of the variable to the first. So in this case, it's the negative 2. The negative doesn't really mean anything because it's going to square positive. So divided by 2 is negative 1, but squared is plus 1. And so I'm going to add 1 to both sides. But let me see what I'm going to add for this side, for the y's. My b term in this case is 6, divided by 2 is 3, squares to 9. So these numbers divided by 2 squared is what you add to both sides. So added 1 here, added 9 here. That means I'm adding a total of 10 to both sides. Then you factor these, but they factor to square binomials. Like if you factored it to a double bubble, it'd be x minus 1, x minus 1. So we write it as x minus 1 squared. And it always ends up being just kind of your b divided by 2. So here's your negative 2 divided by 2 is what goes here. And then for the y's, y squared plus 6y plus 9 would be y plus 3y plus 3. So we write it as y plus 3 squared. Again, it's just your b divided by 2. With a plus in between, because it's a circle equation, that stays. equals to the sum you get over here. Negative 3 plus 10 is 7. And now we're done. That's your circle standard form. X minus 1 squared plus y plus 3 squared equals 7 is choice B. So it looks like a complicated task, but it's really only a couple of steps. You want to group together, move the constant, do your b terms divided by 2 squared, add it to both sides, factor, simplify, and done. So we'll practice these two concepts tomorrow, the circle linear system, and we'll just do one or two examples of this, but then we'll do a bunch of examples on how to get your circle equation through completing the square process.